So, good evening. This will be part 6. So, we're starting part 6. We're going to talk about object-oriented programming. Generally, we won't have enough time to go into all aspects of object-oriented programming. So, there are just a few things that I want you to understand as, being the core concept of object-oriented programming, and hopefully that will help you in the future if you ever need to go into more depth. But what happens in general is that at your level, right? So since most of you are not computer scientists, you're going to go and try to maybe do some analysis, right? Do some data processing, and you're going to have to use third-party libraries. So that's absolutely bound to happen. And you won't need to define your own objects and do your own object-oriented programming, but rather take advantage of the object-oriented object orientation features in those libraries. So you'll have to learn to work with objects even though you're not coding objects yourselves. Right? Most libraries, the ones that are reasonably sophisticated, will have relatively complex objects inside. Most of the time, you don't have to understand them fully. You have to understand only certain aspects of them in order to use the library successfully. And I'm going to try to equip you for that. Okay, so we've learned a bunch of means of aggregation, right? Lists, tuples, sets, dictionaries, right? So putting more stuff into one place. That's essentially what aggregation means. But if you remember a while ago, we showed that this is also possible with functions. And I'm going to remind you that. All right? So I can define, maybe let's do it here, a function, and we called it at that time make person. All right, and we wanted a name and an age at that time, right? And so we want to create this object that actually has two things inside. So I'm going to define a function called dispatch inside, and then here I'm going to have a command. All right, and if is equals get age, then I'm going to return age. All right. If the command else elif equals get name, which I should have started with name, but doesn't matter, I'm going to return name. And I'm going to return from here dispatch. There's one more thing that we should say. And I'm going to throw an error. Did we talked about raising errors, right? Error. Okay, we're learning now. So, really? We didn't? Are we doing it today? I remember writing it. Okay, we're learning it today. So I'm going to jump the gun a little bit. And I'm going to say here that I'm going to raise an error. And the error is unknown command. And we're going to see what happens. So this is an inner function. Yes? Yes, that's true. It's me assignment, and 2 equals are the test for equality, right? And very well noticed. And thank you for that. Okay, so this is one inner function. Okay, And we're going to expand this, right? So you're going to wonder, why do we do this? But we're going to expand this function. So there's an outer function called makePerson, and the result of makePerson is the inner function, right? Not an invocation of the inner function, but just the inner function itself. Okay? So we're about putting stuff inside other stuff. This is what we want to do here. And I am going to read this file, and then I'm going to say p1 person1 is make person of Joe 20, let's say. Okay? I didn't say. Make person without underscore. Okay. With an underscore. So there is one such thing called idiomatic Python. Right? There are some style rules, and I'm trying as much as I can to comply with those. Raise. What's the syntax for raise? Yes, this is it. I didn't do anything wrong. Else needs to have. Then I need semicolon colon here. Okay.
Why not?
Again, please.
You don't have. Why don't you have the same for every document?
I don't have for else. What do I have?
Ls for ls, you don't have columns and then.
I do have the colon here, right? Okay, let's do this again. All right. So p1 equals make person. So the style says that words in a name should be separated by underscores. This is unlike other languages where they want the camel case. Each new word begins with a capital. So we have to be aware of that. So now, this P1 has two things inside, right? The name Joe and the age 20, right? So now I can say P1 applied to, so I can a command get name, yes. Okay, so I can apply P1 to get name, and I will get Joe, all right? And I can apply P1 to get age, and say 20, right? So I have the two things inside P1, right? And interestingly enough, I can't change them. The 20 that sits inside P1 cannot be changed. I can create a different person. Su21, right? And P2 get name. This doesn't really need an underscore, but so P2 get age is going to be 21, right? P1 has remained the same, right? P1 has not changed. So this is like a pair, right? Instead of writing just brackets around Joe and 20, I write P1, but it has the same capabilities, right? I can access each component inside, right? It's immutable, okay? And it has the advantage over a pair that it's generic. I'm telling whoever is using my code that this is a person. I'm supposed to model a person, right? So it's better than just a pair. Computationally speaking, it doesn't have anything extra compared to a pair, but functionally, right, in terms of, because code is not just code, it's a way of expressing ideas and thoughts, right? Uh, we actually saying what is the intent of this code. All right, so we can actually do a bit more. Let's add some commands. So let's say I want to change the age. So one thing is it possible to input a negative age at this point?
Yes.
Yes, it is, right? So Jack and -3, right? We're not prevented at all. Okay. So one thing we should do here is throw an error at the point when we're reading the age, right? So if age less than or equal to 0, raise and before we do that, one thing I should have shown you is what if I input an arbitrary string as a command? Okay, so what you see that has happened now is it's an error, pretty much like all the other errors. So for instance, if I want to say 1 index 2, right, we get a similar kind of error, right? This response is very similar to this well, actually not so similar because error doesn't exist. So I should have had probably here value error instead of just error. Okay, that would have been better. But you see the raise instruction does something similar. Raises an error, right? So we have a uniform treatment of the entire uniform treatment of conditions that are not we're not supposed to be able to handle. Okay, so if age is negative, we should raise an error. Yes? No. I mean, you can, but it's not as good because you're not right. So if whoever reads the message is a human, then they understand it's an error, right? But what if this is a piece of code that is used by another piece of code? How does that piece of code know that this is an error? Okay? So let's add another command. And let's say we have set age. We want to change the age. So the name maybe doesn't change. We don't allow the name to change, but we want to allow the age to change because people keep getting older, right? And what do we want? We want the age to be older. We never want the age to be younger. Okay. So if command is set age, then I'm going to return a lambda return. So I have to say what the new age is. And actually we don't need brackets. So this is Python. All right. So actually I can't return a lambda. Sorry. I have to do def. And we're going to have a new function called set new age. And this function takes a new age. And in here, if new age is less than or equal to age, we're going to raise value error All right. And what are we going to do? Age is assigned new age. Okay. And what we return here is set new age. So at this point, we don't have a immutable object anymore. And we're going to see how that happens. This is very annoying. All right, so somewhere here, I should be able to replace backslash t with all right, so let's go back and create a person. So first of all, let's see, can we create a person with negative age? No, we cannot, right? Age cannot be negative. Okay, let's create a person with a positive age, right? So now I can do, so P3 applied to get age, this is a command, right? Will give me 20. But I can do P3 set age. And then I want to say that the age should be 19. Okay? Local variable age. There's one more thing I need to do. I have to say non-local age. Sorry about that. Not again. I didn't save. All right, so we create a person and we want to set the age to 19, right? And it says that a person only has to get older, right? But if we set the age to 21, that's fine. And if we get the age now, we get 21, right? So let's try a little bit to understand what we have done. We have created a customized way of aggregation. Okay? It's an aggregate with two components. One is the name, the other is the age. And only the age is modifiable. So we have created a policy of modifying the contents. We cannot change the name, we can only change the age. We could have used a list with two elements to encode a person. We could do that, right? All we need is the age and the name and the age, right? So inside the list, I can change the elements. But that would have allowed me to change the name as well for anybody, right? So, but we want a policy whereby a name should not be changed, right? So because of that, the list is not the right thing to use here. Is this understood? Right? So we want to aggregate, and we want to create policies for access. Okay? And you can see very well that a lambda does the job very well. The ability to aggregate is, all we need is a lambda, is definition, is local functions, essentially. Right? Is this clear? Yeah, actually we can't use a lambda. So, but what we're returning is a function, right? Is that clear? We're returning a function. We're not returning a value. Well, a function is a value, so in principle we're returning, from a Python perspective, we're returning a value. Okay? So that's an important aspect. We want to put things together, we want to control access. Right? Some things we don't want to be visible at all. Some other things we want to be visible only in reading, and some things we want to be visible in both reading and writing. Right? So we're gonna learn how to do that, right, in a way that doesn't require so much magic. Because this looks like a little bit of magic, right? Returning a function is not quite clear why the function works, right? But we want to accomplish something similar. So this brings us to today's lesson. Okay? So similar thing, right? We want to declare a bank account. And instead of declaring a function, we declare a class. A class is a blueprint for objects. We're going to have many accounts. And this thing called bank account here, which we call a class, is the blueprint for all those objects. Okay? Now, every time we create a new account, right, inside the class, that new account that is about to be created is represented by this word self. Okay? So self is the current account operated on by the code in the class. Okay? And we want to put in a balance. All right? The way to access elements inside an object is by the dot. And that we have seen before. Right? We have seen that before. So for instance, we have seen that an object like 3 has functions inside. Right? This add function exists inside 3. And we can have many other things inside an object. Now, guess what? The ability to create an entity inside an object is done with the dot as well, right? So if self.balance is on the left-hand side of an assignment, even though the balance didn't exist before, right? The balance is created, and the value of the balance is given whatever comes on the right side of the assignment. Clear? So we can invent we can come up with as many components as we want. Right? So you can say self.a is self.b is something, right? And you can create as many components as you want. All right? So this is the method that is invoked upon creation of the object. And then we want to do two kinds of things with an account. We want to deposit and we want to withdraw, right? When we deposit, all we want to do is add the amount being deposited, right? So we're going to say self.balance plus equals amount. Okay? Now, when we withdraw, this is a very simple kind of account, we want the balance to remain positive. Right? Maybe it can be non-negative. Right? So, if self.balance, and here I am writing other languages again. If self.balance is greater than or equal to amount, then we can allow the withdrawal. Otherwise, again, we are raising an error. And immediately we're going to explain what this raising of an error is. Okay? So we can take this code. I'm going to do a very simple thing here. All right. So let's ignore that output first. Okay, so create an account, right? And now A1. So one thing that you see is we cannot see the balance, right? So this is one functionality that we may want to add. But I can say deposit. Let's say another 1,000. All right, and then we can't see the balance at all. Oh yes, we can see the balance. Sorry, because I can already say A1 dot balance. Okay, so this self dot balance, once it has been created, is accessible. Okay, is that clear? So A1 dot withdraw, and let's say we withdraw 1999. Okay, and then if I try to withdraw even more, let's say A1, that's true, we're going to get the error that we have raised. Okay, so we have a class. We can put inside this the objects created by the class as many things as we want. So currently we put only one thing, but what we learn here is that we are putting inside not just values, but we're putting inside methods. All right, so this deposit and this withdraw, right, we can say A1 dot deposit, right, which is a entity that is inside, right, A1 dot withdraw. Right? We can create multiple accounts of 10, let's say. What was it? Bank account, right? Bank account. Right? And A2.balance is going to be 10, whereas A1.balance is going to be whatever we left it at, right? So they're going to have completely independent lives. Right? And we can operate on these. Now, let's talk a little bit about these errors. Right? We call them exceptions, or in many other languages they're called exceptions. Okay? And they signify an error condition. Something unusual has happened. Right? And we do that because the code is not always used by other humans, right? It may be used by another piece of code. So what if, right, I write a library that operates with multiple accounts. So I want to create a library where I want to create a function that performs transfers, right? So that function performing transfers is going to try to withdraw from one and deposit into the other. And then what happens? What do we want? What do we do if this transfer function attempts to withdraw an amount that is too large, right? So the failure is going to happen again. Let's try to do that actually. Let's try to do that. So we're going to have account 1, account 2, and amount, right? So we're going to simultaneously try to do one dot withdraw amount right? So let's try to do this and perform a transfer between A1 and A2. So we do have A1 and A2, I think. Do we? A1 and A2. So let's say transfer. Here, yes. Let's remember A1 the balance. So this is one interesting thing, right? We don't want the balance to be negative, but we did not do anything that prevents us from having a negative balance. All right, an initial negative balance. So we are trying to prevent the withdrawal, but we didn't create such a balance, right? So let's do that. If initial balance less than 0, is 50, A1 dot balance still minus 10. Didn't I say Control S? All right. Where is the minus 10 coming from? Minus 20. So where is the A1 coming from? Oh! So this is another thing that happens, right? So we're not prevented from doing this. All right? And that's a serious problem. So that's a serious problem that we can't fix. But I'll explain this a little bit later. All right, so let's just create a new account A2, and this one has $20, right? And we want to do the transfer, right? So we want to transfer A1, A2, and want to transfer $10. Okay, so now A1 dot balance is 10, A2 dot balance is 60, right? We have performed the transfer. If we wanted to perform another transfer of 20, all right, we're going to get an error. right? So the error says attempt to withdraw more than the current balance. Okay, but this is confusing because we're not trying to withdraw, we're trying to transfer, right? So we should have an error message that should be a bit more a bit more explicit. So how are we going to do that? Well, we want to catch the error. So we're going to use the following construct. Try and then accept value error, and then we're going to say so let's do print, which is what you would want it to do, right? Trans all right, so we want to print something meaningful. Okay, there's else is only used with an if, except is used with a try, right? So try means the following: this may yield an error, so we try to do it because we might not succeed, right? We're not sure whether we're going to succeed, so we try to do it. If we don't succeed, then this code is activated. Okay? Again, please. So the only way to fail currently is by signaling a value error, right? This is the only way to fail right now, right? If you don't, yes, no, it doesn't. It's just that it prints an error message that is that says that it's impossible to withdraw, right? And then because the operation that we're doing is not a withdrawal but a transfer, right? Whoever is trying to use the account might find that confusing, right? There are many reasons why you want to catch the error, but in general, an error that is uncaught will stop your program, right? We're not seeing this very clearly because we use the interactive environment all the time, right? But if you would try to create a command line utility or a program that has a GUI, right? The exception that is not caught will stop your program, right? So imagine that an error occurs, right? What you want is maybe it's a recoverable condition, right? Maybe you try to perform a network connection and then you don't succeed. And it's because the network is down temporarily, your network cable there's something wrong with it, right? So this is something you could try to fix and try to attempt again, right? Retry. And you don't want to stop the entire application because of that, right? So you want to catch, in principle, you want to catch. So it's up to you whether you want to catch them or not. But you want at least, I mean, the language should provide you with the capability of intercepting errors and doing something about them. All right? Because very often you may have a program that looks like a finished program, but then you get an idea and say, oh, this entire program actually becomes my library. So previously, because it was an entire program, it was okay to throw errors and stop the program on certain conditions. But now, because this big program has become just a library in an even bigger program, you don't want the errors in that now library to stop your bigger program. So you want to intercept them and say, oh, whenever this happens, let me see what can I do to fix them, right? I can inform the user, maybe the user can do something, right? Maybe a file is missing, but maybe the user can go into a different window and create that file and put it where it needs to be, right? And then I go back to the application and continue. Because even if you save whatever you have in the application, shutting it down and starting it up again may take significant time, right? So you certainly have seen applications that take like 30 seconds to start. I'm not sure if it's still. I haven't seen such applications in quite some time. But in the old days, when stuff would be read from a rotating disk, yeah. So Microsoft Word would take 30 seconds to start. All right. So because of that, you don't want applications to be stopped. You don't want to restart applications, right? Whatever error conditions are encountered inside the program, you want to be able to intercept them, right? Inform the user, right? Maybe the user can do something very quick to restore or fix and then the application can continue to run. Okay, so this is what we're trying to do here. This except essentially is an intercept of an error that may occur here. May occur, we don't know that. We're not sure that it's going to occur. Right? May occur there, and we're intercepting it. And then, right? So, for instance, one thing we could do is reduce the amount by half until the transfer succeeds. Okay, and that was my next thing that I wanted to do. So let's see how this works. Okay, ignore all that output for the time being, and we want to perform a transfer. Right, and we're going to have this error: transfer not completed, insufficient funds in the source. Right, that's because A1 has -10. I'm going to do the trick now and do a 50 here. And then if I do a transfer, now the transfer succeeds. A1.balance is 30, A1, A2.balance is 7, right? So if I try again to do a transfer of 200, let's say, then I'm going to get this message. So notice that this is not an error anymore. Right? An error starts with traceback. Right? This is not an error. This is just a print. I have informed the user. Right? So now, this is actually not the right thing to do, really, because if this program becomes part of another program, there's no way to the new code that is being added to say, oh, this is an error. Right? I would have to parse the message in the code and figure out that this is an error. Right? Yes. What do you mean? Right. So why is that confusing? Well, now you find out that you don't have to do that. All right. So let's try to do something more interesting. If this fails, okay. So if this fails, the failure happens here, and as soon as the failure happens, right, there will be a jump from this point, from the point of failure to the except part, right? Meaning that if anything fails, the deposit doesn't happen. And this is something that we want, right? We don't want to deposit first and then to withdraw. Because in that case, the deposit might succeed and the withdrawal might fail, right? So we want to fail fast. As soon as possible, we fail. Everything that can fail, we try to do first. Okay? So let's try now to reduce the. Have you heard the expression fail fast? So it's a principle in design, right? You design things so that if they are to fail, they should fail fast. Don't waste time, right? Because whatever is failed is incomplete. I don't want to wait. I don't want to wait 2 hours for something that doesn't complete. If I know in the first 5 minutes, if I know that I'm going to fail, I should right then fail, right? If I have gathered enough information from my system so that I know that 2 hours later I'm going to fail, then at the point when I have the information, I should fail, right? This makes sense. Yes.
Why is there a preference to have withdraw first and then stop? There is a possibility of you failing in both the methods, right?
No, deposit can't fail.
Why can't it
Well, where it will fail from? What would fail within the
fail?
deposit?
If there's a syntax error. What if it's a lower chance for it to fail?
Syntax errors are not failures, are programmer how do you call it, negligence, right? No, so there are legitimate failures because of conditions that we don't control. Those are failures, right? Things that have not been properly tested, bugs, right? Those are not failures. All right, so let's try to do that. Right, so well, amount is greater than 0 and not completed. All right, we try to withdraw and deposit, and then we can say equals, actually this is much better if we say completed equals false. And not completed, completed equals true. All right, except, and here we're going to do amount divided equal to. Okay? So we keep halving the amount until it's possible to perform the transfer. Okay? Is this clear? So if the failure occurs here, then we jump here, we halve the amount, and then because we're inside the while, we go again. Right? At a point where this doesn't fail, we will have a chance to perform this assignment. Then completed is true. So when we get here, we're done. Okay? Now, since we're in Python actually, we should take advantage. Let's not use completed, but rather, what can we use here? Yes, very good. Great. Okay? Is this clear? So let's try this again. Let's go back to A1 balance and let's try to transfer 200. And let's see how much do we end up transferring. A2 balance is what? Let me remember. Oops. Okay, so now both of them are 50. So we should end up at 50, transferring 50, right? So A1 dot balance is 0. A2 dot balance is 100, right? So 200 became 100, 100 became 50. At that point, the transfer was possible. Okay. So is it clear how exceptions work, right? Now the interesting thing about exceptions is that you can have many levels of functions, and the exception gets propagated. The exception, the error is an invisible return from every function. So you're returning the actual return value plus the possible exception, or the possible exception, right? So any function, right, you can think of it as returning something, right? Which is, right, the exception or lack thereof. Okay, so not having to worry about exceptions. There is code that is non-failing, or there is code where subcomponents may fail, but the code itself doesn't fail, right? So if you have a piece of code where only the subcomponents can fail, you now have the luxury of not worrying about errors. All right, so. Which one? Uh-huh. Yes. Well, I'm not using completed anymore, right? Do you see completed anywhere else? So then, if I have completed, what purpose would this serve? So then I took it out. Cool. Yes? So there are several types of errors. All right, so everything that has an error, right? And you can also define your own errors. But generally, there's enough of them, and they're pretty much comprehensive. So most of the time, that's all you need. Right? So arithmetic error, assertion error, attribute error, base exception, blocking error, broken pipe error, buffer error, and so on, right? So most of the time, when the value that was passed in as an argument is wrong, what you do is what you use is value error. Yes, you can, right? So typically, you don't want to raise the same error. All right. So if all you want to do is raise the error, raise the same error, actually you don't need to do anything, because that error is automatically raised further up. Okay. So to explain how that works, because I was going to give this example. Let's say you have def f1. Let's take some argument, and here you have a lot of code, and somewhere you raise, let's say, value error. And you can raise it without any argument if you want. Somewhere from the middle, from inside, right? And then there is some more code, and then maybe at some point you have some return, right? Expression. And then you have def f2, right, which has another argument, b, right? And here you have some code, and at some point you call f1. Then you have some more code, and then um, you return some other expression. And then finally, let's say you have an f3, which has an argument c, and then you have some code, and then you call x2. So let's say y is assigned f2 of something, right? And now f2 might fail, right? F1 might fail, right? And because of that, f2 might fail, right? So what do I want to do? I want to deal with that failure. So I'm going to say try here. I'm going to do whatever computation I need. And then I'm going to say except. Blah, blah, blah. So, blah, blah, blah. Okay? So, I don't have to worry about F2 having to intercept value error. All right? So, value error is raised here, goes through F2, so goes from here up to here, and then goes from here up to here, okay? And then is caught right here. So F2 doesn't worry about the error. And that's the very important advantage of using errors in this manner, using try and except and raise. Okay? So this guy doesn't have to worry about the error. And very typically, this F2 is actually 10 functions, right? So this is F1, this is F30, and between F1 and F30 we have 28 functions, right? F29 calls F28, F28 calls F27, F27 calls F26, right? Up to F2, which F2 calls F1, right? And all those 28 functions do not need to worry about the error. The error is raised here and handled here. And everything that is in between, no matter how many layers there are, doesn't need to worry about the error. The error will be very nicely propagated from here, inside here, right? If there's an F3, F4, F5, right? It will be nicely propagated until it gets here where it is handled. Python will do that for us, right? So in this entire sandwich, middle of the sandwich kind of, right? You don't need to worry about the error. So that simplifies coding quite a lot. Okay? This is generally quite confusing, right? And what you need to do is, most usually you won't raise errors. You will have to handle them, right? This part somebody else writes. You only come up with this part, which is the fluff that does your analysis, right? Whereas the heavy lifting is done here. So people will decide how to do very complicated computations, some other, right? And raise a variety of errors dependent on conditions that, yeah, disk is full, you didn't provide the right file, the format is not good in your CSV file, and so on, right? And you will have to be able to react to these errors when you write your software that performs the analysis. Cool? Okay. These are relatively complicated things. It will take a bit of time too. Okay, questions so far? Let's go back to this part. So there's another sophisticated concept that I want to talk about. All right, there is something that I glossed over at some point, right? So, and I should give you a solution. So we were saying that this is wrong. right? We shouldn't be able to do this. We should be able to write the class in such a way that this should be impossible. Okay? And many languages have such mechanisms. There is a keyword called private in a lot of languages that makes certain components of an aggregate unreadable invisible from outside. Okay? Now, Python doesn't have such thing. Python has conventions, right? So they expect users to be polite and comply with guidelines. Okay? So if you name your variable with 2 underscores in front and 2 underscores after, it means that it's private and other coders should not attempt to access it directly. Okay? So that's the rule. When I first learned about it, I said, what? But that's the rule. So whenever you see other people's work or you use other people's work and you encounter such names, you're supposed to not use them, right? So we have already ignored this rule because we've done this, if you remember. Right? So we shouldn't have done this. I violated this rule. Okay? So if you ever get to work in a place that uses Python as a production programming environment, produces commercial software, you will be expected to comply with this rules, right? So none of the code that makes it into that production product is expected to break these rules. Again? No, so now if I go and say this still works, right? But now I'm not supposed to use it anymore, right? So there are tools, software tools that can take this text, this Python code, and analyze it and tell me you're wrong here, you're wrong there, right? And then these would act as filters whenever. So if I work in an organization and I want to submit code, these filters will say, "Oh, your code is rejected." All right, so that's pretty much how it works. But Python itself will not complain. So since we are in this situation and we are not able to access the balance anymore, right? We should provide a method that returns the balance. So typically we would do something like get balance. Okay. Now notice that this is worse than using the previous method that we have used. Right? We have used make person. In make person, we were able to restrict access fully. Right? So the class mechanism is actually worse than the method of using functions or procedures for aggregation. But this is the standard way. Okay? Now, there's one important concept that I want to try to teach you, and it's that of inheritance. So, in object-oriented programming, code becomes incremental, right? They're incremental pieces of code, all of them contributing to a bigger goal. And then we can change these little pieces. Each piece can be changed at any time. Okay? So we're going to create a hierarchy of objects, and we're going to learn in this way about inheritance. So let's create a person. Okay? And this person has a name and the date of birth. Okay? Some attributes. We don't care actually about the attributes. We don't really. Name would have been enough. Okay? And a person has an ability, right? Has a feature, has an ability. The ability to say things. Okay? So when the person says something, it simply prints. And we're going to say, what's the big deal? Why not use print directly? But bear with me for a time being, right? So it prints. It has the ability to say things. All right? We create two persons, and we can verify that these persons have the attributes, right? And we can also verify that a person has the ability to say. Okay, I'm gonna comment about this next time because we don't have time. So we can add attributes after the fact. That's true. Let's talk about it next time, right? And let's not worry about it right now. Okay. So next, I want to create a new type of person. So initially we created person. All right. So I can create a student who would be a person, and then notice that I say in brackets person. So student is a person who has a few more attributes. It has all the previous attributes, the one that a person has, plus some more attributes, right? So what do we do? Person had the ability to initialize an instance. So we're going to go and say, oh, initialize the person part of the student. So the super refers to the person that lives inside the student. And then let's add one more attribute, a major, let's say, right? So now Bill will be a student and born in 1996, whose major would be psychology, right? What do you mean? Here, this first and this, or what?
So like you think Bill mentioned psychology.
Yes. Right, but one thing you can do is say name, then DOB, then major, and then you can mix them. Right? Okay. All right. So, a new type of person, it would be lecturer. Right? So notice something that Bill, even though we didn't try it here, Bill has the ability to say things. Right? Inherited that. So we're talking about inheritance. Inherited that from the person. Because a student is a person, so and a person has the ability to say things. Right? We created that ability here, and then the student, being a person, has the ability to say things. So I could say, Bill say. All right, and Bill will say hello. Now, a lecturer is another kind of person, and the lecturer, besides the ability to say, which is what is inherited from person, also would have the ability to lecture. And whenever the lecturer lectures, it simply says what it has to do, and then it adds, you should be taking notes. Right? So, I'm a lecturer, and all right, these are my we didn't give anything okay, so you see the lecturer doesn't even have its own init, right? So it relies on the init of the person. So we give it a name, we give it a date of birth, right? and then we say, Razvan say the sky is blue, and then this is say, right? And then we're going to have Razvan says the sky is blue, right? But if Razvan is asked to lecture, then Razvan is going to say the sky is blue, and then you should be taking notes, right? So notice something about reuse, right? We have three classes of objects now. We have person, student, lecturer. All of them rely on this method say. Now, let's say that instead of printing, I want to go to, I have a voice interface. I have a voice library, and I have the ability to um, um, uh, make the voice, put the voice through the speakers of the system, right? So instead of doing printing, I can replace this with something that um, uh, just sounds, makes the sound of, or utters the phrase into the loudspeaker, right? And how many places do I need to change? I have three types of objects, but if I want to make all of them speak through the sound system, through the speakers, then how many places do I need to change? Only one, right? Only here. Everybody relies on the capability to say. So this is why it's useful to create. You're saying, oh, well, say, what's the big deal? We're just printing a string. Why not use print directly? Right? We're creating this shortcut because later I may want to change this into something else. And then I don't have to change it everywhere. I have to change it only in one place. Okay? Yeah.
Why do you define say because in the actual like class version, that in itself maybe cover
But I may want to say many times. So later I may want to say the sky is green. And then later I may want to say something else. If I put it in init, it's only one time, right? Okay? So now pay attention. Pay super attention. All right? Be super attentive. So we create an arrogant lecturer. And an arrogant lecturer is a type of lecturer. All right? Type of person, not right? So an arrogant lecturer is a type of lecturer, which lecturer is a type of person, right? Right? So we're defining inside here a method called say, even though there is a method called say inside person. Okay? And because this is an arrogant guy, right, we're going to rely on the underlying say to say whatever the lecturer would say, but prepended when it is obvious that. Right? So we create an arrogant lecturer, we'll call him Albert, based on the fact that Einstein was not a very humble guy. All right? And we have Albert say the sky is blue, right? So Albert says it is obvious that the sky is blue, right? Which is expected. So this is the say of the arrogant lecturer, right? The super is the lecturer, right? Which doesn't have its own say, but there's a person inside there that has its own say. So super.say goes to the say of the person. Cool? So far, cool, right? So now we ask Albert to lecture. Albert lecture the sky is blue. And Albert says, it is obvious that the sky is blue. It is obvious that you should be taking notes. Right? So this is somewhat surprising. Okay? So we're asking Albert to lecture, right? Albert doesn't have a lecture method, but the lecturer does. So we're going to the lecturer and we're lecturing, right? And then how does the lecturer lecture? Well, it says some stuff and then it says some other stuff. So when it says stuff, which say is it being used?
The one in the
The one in the subclass, not super. The one that is defined here. Right? So we're inside a big arrogant lecturer, right?
so you don't have a say function in the person.
Yes, there still is one. But every time you search for the say, it doesn't matter what level you are, you go at the top level.
So there is one in the person, right?
Yes?
So shouldn't lecturer call
No, that's the thing. So that's what most people expect, and that's actually the subtlety here, right? So every time when you look for a method, right, you go to the outer level. So you're inside an arrogant lecturer.
Outer
because it
level of
overrides.
The arrogant lecturer, right? The arrogant lecturer has a lecturer which has a person.
Because
Right?
it overrides the previous
Yes.
method.
But that's the point. You want to have the ability to override, right? So you want lecture. There's no lecture here. There's lecture here. Lecture uses say. Where do you start? Where do you look for say? You go to the top again. There's a say here because we just defined it here, right? So every time you look for a method is a matter of search now. I have an object and I ask the object do something, right? So the outer object says, do I have the method? No, if I don't have the method, let me look at the inner level, right? Does that one have the method? If not, does that one have an inner level, right? If that inner level has the method, if not, we go to up to the base level, right? And obviously, if there's no method, there's an error. But let's say somewhere that method is found, then that method uses another method, calls another method, right? So lecture calls say. Where do I look for the new method? Go big again. Okay? So in this way, right, the arrogant lecturer replaces the say method pervasively. Right? So this lecturer didn't know that it was going to ever use this method. At the point when the lecturer was written, the lecturer didn't know that the arrogant lecturer will ever exist. Right? So the expectation is that because the lecturer has an inner person, this is the say of the person. But no, right? It is the say of whatever encloses the lecturer at that time. Right? So we have pervasively replaced the say at all levels. So this is a fantastic property and feature, right? It allows granular replacement of code, right? You have a very big library, but then because of the object-oriented philosophy, you're forced to break your code down into small methods, and then you can replace any of them. It doesn't matter how the hierarchy is built; you can replace any of them.
If we go back to person and then we just get rid of say all of them,
Then you're going to have an error.
because lecture wouldn't be right.
No, actually, no. It won't. In Python, actually, there will be no problem. Right. So you're gonna have an error here, right? You're going to have an error um, for Razvan, but this one will not be an error.
No, but it doesn't.
This one will not be an error. This one will not be an error.
Yeah. So because lecturer it calls on.
Oh, it calls on this one. That's true. So then, because of that, it's going to be an error.
So there will be.
There will be an error. Yeah.
No.
But then I could make this print, right? So I could remove the say in person. I could make this print, a print, and then there will be no error for the arrogant lecture.
Without using simplification, it would always down.
Yeah.
Okay.
But if you were in a language like Java, you would have an error. Java, Scala, C++, all of them will require the method to exist at all levels. At least be declared virtual. Okay, so if you understood this, you understood the two main things and possibly three main things of object. So there's still three things in object orientation. There's aggregation, there's encapsulation, and there's inheritance, right? Python doesn't have encapsulation. It only has it as a convention, right? So you put the two underscores. But aggregation is there, right? You can see how you can put many things inside an object. And then inheritance is there, right? And inheritance is actually the more important property of them, because what you want is to customize code in right, to take advantage of a huge code base. You have a huge code base that does 99% of what you want, but there's the 1% missing. And then you would like to replace that 1% with your own thing, so that it actually does what you need. And with object orientation, that becomes possible. It's not that it wasn't possible before. It was a lot more difficult to obtain, right? So object orientation enforces this philosophy. Is this clear? Okay. So typically where we go from here in an object-oriented programming course is try to show how this is very useful in data modeling, in building hierarchies of abstractions, and so on. We won't have any time for that, right? So this is a pretty sophisticated tool, and if you don't see how it is really used, you probably won't get the feeling that it is very useful. It is very difficult to find simple examples where it is really useful. So nevertheless, object-oriented programming is the de facto standard for code development nowadays, right? So the languages that are most widely used currently are C++ and Java, with Python on the rise, and all these three languages are object-oriented, right? And their success comes from the fact that they are object-oriented. Cool. So if you're really interested, which if you're not a computer, you don't have a computing major, you're probably not. There are many books, and probably Python is not the best example of object-oriented language, nevertheless. So you might want to pick something like Java. Pick up something like Java. Okay? Questions?
Is the next assignment going to be
Maybe a little bit. I haven't decided, so I'm going to make it on. I think that what we discussed last time was, yeah, data analysis was slightly more useful to you. So I would like you to practice that rather. So I'm going to ask you to read a file from somewhere. Again? Well, so you're getting towards 30%. Each assignment will have a very large weight, right? So they have to be longer, because then otherwise, if I give you 3 questions and each of them is 10%, then I'm going to be happy about that, right? So at least to give you a chance to solve some of it, so that you at least come close to your target. Cool. Thanks for coming. See you next time.